And then this is like, hopefully, anaerobic digestate, and it's like, just like all bacteria and archaea.
My name is Maliea Holden. I am from St. George. I love St. George. Some people affectionately call it St. Gorgeous, which I think is very suiting. When I was younger, my brother was a graduate student at University of Utah in the chemistry program, and I went to visit him, and he worked downstairs in the lab, and I remember walking through it, and there was like beakers and flasks, and I swear it seemed like a mad scientist lab, and it was so fun to see everything, and I was like, oh, this is real, and this is science. And on the flip side, it's fun here now because when people come to visit me in the lab, they're also like, whoa, there's like pipettes and there's beakers and flasks, and they're like, you're a real scientist. And I think sometimes I forget that I am. I love PhDs because you take a problem that's extremely complex and hard to understand, and you break it down into smaller pieces, into smaller questions that you can answer. And then you start getting these answers, and the answers start building up until you get complexity back again and you understand more of your system that you're trying to study. Science is all about questions and making those questions simple enough to answer, and then learning from those answers. So our project in the Andrew lab, we lovingly like to say it's poop to power. And what that entails is we take some sort of organic waste like sewage or manure, and we feed it to this big pot of bacteria and archaea. And that bacteria and archaea, they start to break down the long carbon chains that are found in sewage. And they break them apart until you have just one carbon and with 4 hydrogens, and that's methane, and you can compress it or you can combust it and use it as a source of renewable energy. So we want to take as much solid carbon as we can and push it into a gas form. And by doing that, we accomplish 2 different goals. The first thing is that we reduce the amount of solids that are left at the end of this process. So this is important for like wastewater treatment plants because their whole goal is to take all of the sewage and to reduce the amount of it because it's costly to take those solids and put it into the landfill. The second part that we're working to improve upon is to increase the amount of gas that's produced because that gas can later get used as a source of renewable energy. Sometimes when manure bottles are exploding and I have sewage leaking out everywhere, I think, wow, this is not where I thought that I would end up, but I am really glad that I did. I just love the end application that our project works with. I see the direct influence on wastewater treatment plants or on dairy facilities. Our technology is implemented on a few different dairies across the states, and so we help manage their waste. I'm really glad that I ended up in this lab and on the project that I'm on. My favorite part about being in the microbiology department is the people. I love working, first of all, in my lab. My lab is wonderful. We're all really good friends. There's party hats sitting up on my desk from all the parties that we have and the ways that we celebrate each other. I love working for Dr. Underwood, and the MMBIO department is extremely supportive. I enjoy spending time with my friends. I've made a lot of friends at BYU, and I think that's one thing that set apart my undergraduate degree from my graduate degree is I learned that community is a really big part of being a scientist and a big part of my own life, and making friendships within my lab has helped me enjoy work more, and it's also helped me enjoy like my free time. And that's something that you might not like always expect out of a lab, but it really makes the time go by, and it makes things a lot more enjoyable when we work together, and that's something that I think our lab does really well.